60-second adventures in microgravity. Number 1. What is microgravity? Gravity is pretty useful. It keeps our feet on the ground, ensures the Earth orbits the Sun, and shapes the whole universe. But sometimes it would be really handy if it wasn't there. Because when gravity acts on something, there is always an effect. Usually from the other forces counteracting it, like the ground pushing back on us, which we perceive as weight. So to understand many physical and biological processes, it would be better to take gravity out of the equation. But that's impossible. So instead we create an environment on Earth in which, as far as possible, all these other forces are balanced out. So the thing we're studying appears to be weightless. We call this environment microgravity. There are many ways to achieve microgravity, but one of the simplest is by using something called a drop tower, which is, well, a tower you drop things off. So relative to each other, objects become weightless and are in an environment of microgravity. But only for a few seconds, until they're back down to Earth with a bang. 60-second adventures in microgravity. Number 2. The Vomit Comet. When you're on a roller coaster and you feel your stomach being left behind, for that tiny moment you're experiencing microgravity. And we can use microgravity to study how planets like the Earth are formed, when tiny ice and dust particles collide and somehow stick together in space. To test how this happens, the particles have to be thrown together very gently, or else they break up. But at that speed on Earth, gravity acts on them and they don't even reach each other, like a really pathetic snowball fight. So scientists head off on something called a parabolic flight, where a plane travels in a series of huge parabolas or curves. As it goes over the top of the curve, the pilots adjust the plane's speed to counteract the effects of gravity inside. And for about 22 seconds, we can create a microgravity environment to test these planet-building collisions. Just like a 4-hour roller coaster ride, which is why they call it the Vomit Comet. 60-second adventures in microgravity. Number 3. Bed rest. Being an astronaut might sound fun, but spending too much time in microgravity can lead to problems. As blood rushes to your head and your blood pressure drops because your heart doesn't need to work as hard. Over time, this can permanently affect your vision, and because you don't have to use your muscles and bones as much, in microgravity, they start to waste away, all of which resembles the effects of aging, teaching us quite a lot about the aging process itself. Though, while astronauts are good guinea pigs, sending more of them into space would be very expensive. So instead, we ask people to spend a lot of time in bed, up to 6 months, because we've learned that lying with your head tilted down by about 6 degrees can simulate the effects of microgravity on blood flow, muscles and bones, and even the immune system. In this way, scientists can study a large sample of people for the effects of aging, as well as the consequences of long-duration space travel. All very convenient, apart from dealing with the bedpans. 60-second adventures in microgravity. Number 4. Space bugs. Space travel can be a bit of a challenge, not just because of what you might miss, but because space vessels can become heavily contaminated with Staphylococcus, which might sound like a dinosaur, but is actually a type of bacteria. But sadly, in space, getting things clean isn't very easy. In fact, the first astronauts were worried that in microgravity environments, bacteria would become more powerful and resistant to antibiotics. So because of all the effort and cost of working in a space environment, scientists recreate the effects of microgravity on Earth and experiment on bacteria in a very clever rotating chamber, where the bacteria can breed and multiply, but don't know up from down. At a first glance, the bacteria appear to live and die very similarly to their Earth-born siblings. But it turns out that in microgravity, bacteria are likely to be less virulent than on Earth, which is not only good news for astronauts, but also good news for research into bacterial resistance and helping to keep things clean.